This is our last video in Chapter 5. I'm working on the Check Your Understanding on page 331. During World War II, the British found that the probability that a bomber is lost through enemy action on a mission over occupied Europe was 0.05. Assuming that missions are independent, find the probability that a bomber returns safely from 20 missions. So, first of all, notice it is asking us the probability that they return safely. And the original number that they gave us was whether or not they were lost through enemy action. So to find the probability that they returned safely, it is a complement of them being lost. So it would be 1 minus 0.05, giving us a 0.95 probability that they returned safely. Now, that would be on one mission. To find the probability that they returned safely on 20 missions, we have to use the fact that, having a hard time talking and writing at the same time. All right, here we go. So the probability they returned safely on 20 missions is because they are independent. I'm going to put that in my answer, that they are independent. Because they are independent, I can multiply them together. So I would be doing 0.95 times 0.95 20 times, and we know in math that means we're doing 0.95 to the 20th power. And if you put that into your calculator, you will find that it is a 0.3585 probability. So about 36% chance that the bomber will return safely from 20 missions. Yes, I do want you to make sure you include this fact of independence, because this rule that we're using here is a conditional rule. It only works if your data is independent to begin with. So make sure you have that in your answer, even though it's already there. And notice I underlined it too, but I still wrote it here. Don't just underline it because I'm only looking at your answer. I'm not looking back at your question. And then the second question here in the Check Your Understanding. Government data show that 8% of adults are full-time college students and that 30% of adults are age 55 or older. Because 0.08 times 0.3 is equal to 0.024, can we conclude that about 2.4% of adults are college students 55 or older? Why or why not? First of all, I like the conclusion and the fact that they wrote it in context and put it really nice for us there. Remember what I just got done talking about. This rule that we are using, the rule that we used up there and the rule that they're trying to use here of multiplying them together, is conditional on the fact that we have to check to see if the events were independent to begin with. If we don't know that the events are independent to begin with, then we cannot use the rule. And it doesn't say anywhere in here that they are independent events. So we're looking at adults in college and their age. Likely not independent events. So because we don't know if they're independent events, we cannot use that rule. So no, the condition to using this rule is that the two events must be independent. Being a college student and being 55 or older are not independent events. So there's a couple of different rules in this chapter. Some have conditions, some don't. We have general rules, and then we have the more special case rules. Be sure if you're going to use a special case rule that you're first checking the condition, and if the condition is met, make sure you write it down as part of your answer. Good luck. This is a fun chapter if you're able to kind of understand it and play with it a little bit.